Okay, so in this video, we are going to go through the rules and some examples for covalent, which is also sometimes called molecular nomenclature. So when we're talking about nomenclature, we're talking about the specific rules used to write properly balanced formulas and correctly composed chemical names of compounds. And we're going to break this up into two parts. We're going to talk about the covalent rules first, and then I will do a separate video that goes over the ionic rules. They're a little bit more in depth, and there's a couple different types. But this is definitely the shortest of the two. So first of all, covalent nomenclature governs compounds where both parts of the compound are nonmetals. Sometimes metalloids will also make an appearance, but usually nonmetals. So when we say nonmetals, remember that if we look at our periodic table, we have this stair-step dividing line that separates the metals, which is everything to the left of that stair, with the nonmetals, everything to the right of that stair. And we say everything, remember that is loose everything, because you do have some things that are in certain places based on their electron configuration. For example, hydrogen, which is for sure a nonmetal because it's a gas, lives over here on top of our alkali metals because of its electron configuration. And then we know helium, which is also a gas, lives over here on top of the noble gases, when if you looked at it by electron configuration, would really live over here next to hydrogen. So when we say everything, and that is a generalization because your nonmetals, which is all this over here, does include hydrogen. Hydrogen as a gas is a nonmetal. Okay, so we're looking for two things that come from above the stair-step line or hydrogen combined together in a compound. And some important things to remember when we're talking about molecular or covalent nomenclature is that we are disregarding the charges of these particular elements. When all of the things come from above the stair-step line, you got to remember that a good proportion of them are going to have the same type of charge, meaning both negative or both positive, and we can't balance charges. So we have a different set of rules for covalent, where we ignore charges, than we do from ionic, where we use charges. Okay. So because we have to ignore charges, we're going to use prefixes to represent the number of atoms in the compound. So when I'm writing the chemical names, you're going to see some prefixes in front of the name of the element. When I'm writing the chemical formula, we will look at what the prefix is, and that tells me how many I have. So the prefixes that we're going to use are these: mono, which represents 1, di, 2, tri, 3, tetra, 4, penta, 5, hexa, 6, hepta, 7, octa, 8, nona, 9, and deca, 10. And usually it's this set of 4 through 7 that if you're going to have trouble remembering which one's which, it's those 4 that usually people kind of have difficulty remembering. And so the way I'd like to think about it is like the Pentagon, the building in Washington, D.C. What does that look like? How many sides does it have? Oh, it has 5 sides. A hexagon, how many sides does that have? 6 sides. If you can kind of remember that, that maybe will help you to figure out which prefix we need to use. Okay? And there's really only one big rule here. You don't use mono on the name of the first element. You can for sure use it on the second element with no problem, but you don't use it on the first element. And even though we haven't gone over any examples yet, you are familiar enough with some of these that I can use this one as an example. So we know that carbon dioxide is represented by the formula CO2. It's carbon dioxide because I've got 1 carbon and 2 oxygens, which is, there's your prefix di because there's 2. We don't call this monocarbon dioxide. That would be weird. We just don't do that. But if we do have the situation like CO, right, you guys know that CO is called carbon monoxide. So we can mono the second part, just never, ever, ever the first part. Okay. And we're going to make sure that when we are writing the name of the second element, we change the ending to IDE. It's just how we do it. So we're going to go through some examples of writing names to formulas and formulas to names using our prefixes. So I'm going to refer back to this list of prefixes as we go as needed. All right, so we'll go through these a little chunk at a time. So for the first one, dinitrogen tetroxide. So this one is tetroxide or tetroxide. When you have the two vowels there, usually one of them drops, and it's generally the one associated with the prefix. As you do these, when you say them, it kind of becomes apparent where the vowel should drop. So we'll go through this one at a time. Dinitrogen. So di is our prefix that tells us we have 2, and tetra is our prefix that tells me I have 4. So when I'm writing the formula here, my formula is I have 2 nitrogen, I have 4 oxygen. So N2O4 is the proper formula that corresponds to the name dinitrogen tetroxide. Okay, I literally just write down what it says. All right, for the next one, hexasulfur dioxide. So hexa, like hexagon, 6. Di, again, is 2. So hexasulfur is 6 sulfurs, S6. And dioxide is 2 oxygens, O2. So S6O2. All right, let's look at 2 more. Pentacarbon trihydride. So penta, like pentagon, is 5. So 5 carbons. Tri is 3. Hydride. Remember, we changed the ending to IDE, so you got to kind of change it back in your head to know that this is hydrogen. So we've got 5 carbon, so C5, and trihydride, 3 hydrogen. Okay. All right, let's look at this next one. Arsenic heptafluoride. Well, notice that there's not a prefix on arsenic. So what does that tell me? Well, if there's not a prefix, and I know I can't mono the first thing, the lack of prefix tells me that I just have 1 arsenic. And then hepta is 7. Okay, remember, if you look at your prefixes here, hepta is 7, heptafluoride. So I have arsenic, which my formula for arsenic is AS, and then hepta, 7 fluorides. All right, and last 2 going this way. Diantimony pentoxide. Diantimony pentoxide. So di is 2, and pent, or penta, again, is 5. So when we're doing diantimony pentoxide, we've got SB, because that's our symbol for antimony, 2, pent, 5 oxygen, so 5 oxygen. All right. And our last one here, dihydrogen trioxide. So di, 2, tri, 3. So I have 2 hydrogens, H2, and 3 oxygens, O3. So the nice thing about when you're going from names to formulas for covalent is you literally just write what it says. If it says I've got di of something, I know I have 2. If it says I have tetra of something, I know I have 4. I just write what it says. Make sure you're using the appropriate format for writing your chemical symbols. What should be capital needs to be capital. What should be lowercase needs to be lowercase. Your numbers should be subscripts. There should be a clear differentiation between those capital and those lowercase and what we have as a subscript. But other than that, you just write what it says. All right, so now we've gone from names to formulas. Let's go the other way. So given the formulas, write the names. So remember, the only thing that we've got to remember here is that the end of the second word, just like we saw up here, changes to IDE. We don't change the first word. So let's break these ones down. So N3O6. So we've got 3 nitrogens. So what prefix should I be using? So 3, remember, is tri. And then we've got 6 oxygens. So the prefix for 6 is hexa. So now I'm just going to put that together. So I've got tri-nitrogen, and then hex. And remember, with the 2 vowels there, we're going to drop the A, so it's going to be hex oxide. We're going to change the ending to IDE. Okay, and if you put it as hexaoxide at this level, I wouldn't mark you wrong, but it does get dropped. All right, for the next one, we have P5H2. So P5, 5 is penta. So we've got 5 phosphorus, and 2 is di for hydrogen. So now we put it together. Penta, phosphorus, dihydride. That hydrogen ending changes to IDE. Okay. Next one. So we've got C3Cl, so we know 3 is tri, so 3 carbons, and then how many chlorines do we have? I don't have a subscript. So if I don't have a subscript, I know that means I have 1. Prefix for 1 is mono. Okay, so tri with the carbon and mono with the chlorine. This is going to be tricarbon monochloride. Okay, and again, remember, you can mono the second thing, just never the first. All right. Se9Br3. So 9. That's not one we use very often. Remember, 9 is nona, Nona. So let's write that down, Nona. And 3 we know is tri. So nona and Se is selenium. So nona, selenium, tri, and bromine is going to become bromide. Nona-selenium tribromide. All right. And looks like we've got 2 more examples. So for this one, CO3. We don't have a subscript on the carbon. We know that means there's 1, but what's the catch here? Remember, carbon's in the first position. I don't mono when it's in the first position, so I'm just going to write this down as carbon. So carbon, and then 3 is tri, so carbon trioxide. And then our last one down here, Si3S7. So 7, remember that's not one of those we use super often. 7 is hepta. So tri for 3 and hepta for 7. So tri, and what's Si? Si is silicon. So trisilicon, hepta, and sulfur becomes sulfide. Okay, so it's the same pattern over and over again. We see that we're changing the ending of the second part to IDE. We don't change anything about the first part, and we just add the prefixes as appropriate. So those are our rules when we're dealing with 2 nonmetals, which would be covalent or molecular nomenclature. Okay, and that should be everything you need to get through the covalent section of the assignment.